almost finished. We almost finished the example for the polynomial of least degree. Polynomial of least degree, we left off here. Okay, we left off right there finding the polynomial of least degree. You were absent, right, Zelene? Oh, let me get some notes out to absent people from yesterday. Do you have it? Oh, yeah, okay. Yeah. Okay. Does anybody need the notes from yesterday? Colin, 7-1 and 7-2. It's titled Polynomials. Anybody else? Oh, shoot, there are 2 pages to it, Colin. My apologies. You need them? You weren't here yesterday? I mean, of course I noticed you weren't here yesterday. Okay. Natalia? All right. So the top of it, those of you who were absent yesterday, the beginnings will look really confusing, but I'm sure the people around you will help you out on what you missed. It's really not too terrible with the Q's over P's. We are. So we were to write the polynomial of least degree at the top of it. The roots of this polynomial were plus or minus square root 2, plus or minus 3i, and 1. So we got to here. Allow me to emphasize something. In my notes, I put plus or minus square root 2. In my notes, I put plus or minus 3i. The book is going to try to trick you. Whenever you have a radical root, whenever you have an imaginary root, it will always, 100% of the time, come with the other side of it. So in your book, it might tell you that the roots were negative square root 2, positive 3i, and 1. If it only says positive square root 2, there's a negative square root 2 there as well. They're just trying to fool you by trying to make you not realize that there's a partner that comes with it. If they tell you negative 3i is one of the roots, well then positive 3i was also one of those roots. Because really quick, how do we get a 3i? The only way we could get 3i is if we had x squared equals negative 9. And if I square root both sides to get 3i, what goes in front of that? Plus or minus. So the only way I can get that imaginary number is by square rooting, so it'll always have a plus or minus. The book might not put the plus or minus in front. If you see a square root, if you see an imaginary number, it has the plus or minus in front. So we ended off here. This is just distribution and combining like terms. Really, I highly recommend, as always, work from the right 2 parentheses, not the left 2. I am going to, for this example, work from the left 2. We've done this before, working from the left. It will work out just fine. But I had students, and this is what I warn you guys, I had students 3rd period who worked it out from the left like this, but then they mess it up when they distribute from the right. And that's the only reason I warn against it, just because your eyes don't work right when you do it that way. So x squared times x squared is x to the 4th. X squared times 9 is 9x squared, minus 2x squared, minus 18, times x minus 1. Combine like terms. Oh, this had a squared on it, sorry. So the issue was, when she went and distributed the left to the right side, she distributed wrong. You just have to watch yourself. As long as you make sure you distribute correctly, you can do it this way. You can work from the left to the right. So from here now, I can distribute, but I'm going to distribute this way. X times x to the 4th. X times 7x squared. X times negative 18. Negative 1 times x to the 4th. Negative 1 times 7x. Negative 1 times 18. There are no like terms to combine. I could call myself done. If we'd like, we can write it in descending order. Oh. there's something wrong here. That's how it's squared. So, no. Almost fell off. Kaya? So the last part. Oh. That was, we literally left off from there yesterday with our notes. That was the last step we left. We started a whole problem and we were halfway through. Are you casting a spell at me? Oh. It back. Ah. So. That would be it. That's the polynomial of least degree. They might want you to throw an f of x in front of it, you know. Why not? Okay. That's standard form to put it in descending order, correct? Do you have to? No, I'm not going to bust your chops over that. It's a good habit. Are you on a phone at all? Put away. All right, the last question. Now we're going to use some meta knowledge here. In other words, meta knowledge would be like if we had, let's say, we were working. Let's talk about. I have no idea what I'm going to say right now. Everything drained out of my brain. Bruh. There you go. If we had adding and subtracting polynomials, and I threw a question at you, and you were like, I wonder what I'm supposed to do. What do you think you'd probably have to do? Add and subtract. That's using the meta. So if I just gave you like a random problem in the very beginning of the year with no context to it, you might not know what you're supposed to do with it, right? But if we're falling under the heading of 7-2, right? So if we look at the heading of 7-2, and we're working in 7-2, and it says finding complex solutions, then more than likely every problem I'm going to throw at you has complex solutions, right? So we can use that meta knowledge. Now on a big state test or something, we can't use that knowledge so much because of the fact that we don't know whether or not it has complex solutions. Can somebody read off to me that problem on the next page or the previous page or wherever we were? Yeah. Notes. Right. So we're going to, it says solve the equation. Now this is not an equation, so that's my bad. This should equal something. There we go. So it says solve it. Solve it. So we're going to find all the roots. Now since this is in 7-2, we need to understand there's a good chance that there are complex roots in this solution. Unfortunately, our Q and P's only find rational roots, not complex ones. But let's go and find all the rational roots that we possibly can. So let's go ahead and figure out our Q and P. What are our Q values? One, two, 3, 4, 6, 12. Okay. What are the factors of P? 1. Haha. It's always nice when our P is 1 because of the fact that when we do all of our options of Q over P, it's just the Q's, right? Because it'll be like 1 over 1, 2 over 1, 3 over 1, 4 over 6 over 1, 12 over 1. So our Q over P is going to match our Q's perfectly because of the fact that our P is 1. Question about Q? Q is factors of 12. No, Q is just the last number in here. P is the first coefficient. All right, so we're going to try to find our rational roots. How many roots does this have total? How many zeros? 4. Why 4, Holly? The exponent, the highest exponent is 4. This has 4 roots. Some of them are probably complex. Complex roots are the square roots and the imaginaries. Those are complex roots, and they always come in what? They always come in pairs, a positive and a negative version. So either all 4 are complex roots, or how many? Or 2. If 2 are complex roots, that means I have 2 real roots. If all 4 are complex roots, that means none of my P over Q's will work. Let's give some a shot, though. Don't forget, if you were absent yesterday, I forgot to repeat myself in third period, and the absent people started writing my guesses down, and then I'd erase them, and I'd see them having to erase what I wrote. So don't do that. Well, this part's for sure, because this is just the synthetic division part, but not the guess. That's the for sure part. The guess is what we don't write down. Nicole, where are you from? Brazil. Because Martina showed me on her phone what it's called in... Huh? Raffini. Yes, Raffini. Have you ever heard that? Raffini's? What? Just method or something? What? Yeah. Oh, yeah. Right, which is why I always show the steps, so that way I don't forget how to get there. All right. Yeah. I got you. Gabriella, give me your guess. Hit me with your best shot. 1/2? That's not one of my options. -1 or 1? Which one do you want? 1. So we don't write this down, people absent yesterday. We go 1. 1 times 1 is 1. -2 plus 1 is -1. 1 times -1 is -1. 1 plus -1 is 0. 1 times 0 is 0. -8 plus 0 is -8. That's not going to get me there. Right, so I mean, you could almost say, you could fill it in, I need that to be 12, so that could be 0. Right, so we need that to happen. What are we trying? 2. 2. 1 times 2 is 2. -2 plus 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. 1 times 2 is 2. -8 plus 2 is -6. That would have given me -12. Wah, wah, wah. What about -2? Would you like me to try it, or you just want to talk about -2 for a bit? -2. 1 times -2 is -2. -2 plus -2 is -4. -2 times -4 is +8. 1 plus 8 is 9. -2 times 9 is -18. -26. Wah, wah, wah. 3, my lord. 3. What did we say? Oh, we should have been putting down. What have we tried so far? 1, 2, -2? All right. -1. 1 times -1 is -1. -2 plus -1 is -3. -1 times -3 is 3. 1 plus 3 is 4. 4 times -1 is -4. -8 plus -4 is -12. -12 times -1 is +12. Ding, ding, ding. We have a winner. Okay. Yep. So since we found one real root, now remember, complex roots always come in pairs. So we can have 2 of them, we could have 4 of them, we could have 6 of them, but we can't have 1 of them or 3 of them. So if we know that we're going to have 0, 2, or 4 of them, well, we already found out that one of them is not complex. If we find one non-complex, There's got to be another non-complex because I can only have 2 complex, not 3. So another one's got to work. Dimitri thinks it's a 3. Was that Dimitri or is that Alfaro? Oh, Alfaro thinks it's a 3.
So do you always have to take it from like that? Like
You don't have to. You could go back to the original numbers if you wanted.
does it make a difference?
It's just a shorter computation. Okay? So we'll try 3. Don't try it until we find out it works, folks. 1 times 3 is 3. 0, 0, 4, 12. Ding, ding, ding. Works. So, I know I heard you, Bethany. We were 3, my lord. 3. Elias, are you high-fiving ghosts over there? What's... I look over at Elias and he's just like... Higher. There you go. What's up, Elias? That's not, I do that. I put a little, to let myself know that's the remainder. I give myself a little fat line. I warned you when I did this. I said, sometimes you'll see me slap that down there. You got to watch out because I just do it subconsciously. Didn't I warn you guys about that?
No. It sounds familiar, but it would be weird.
Alrighty. Now, guys, what was the exponent on this? 4. This. 3. This. 2. I'm down to an x squared. I'm going to save us some time just because of the fact that I'm going to use the meta knowledge that we are in finding complex solutions. We've found 2 non-complex solutions. This is a section where we have complex solutions and they only come in pairs. So the 2 solutions that go to this must be complex. The 2 solutions that go to this must be complex. Now you have 2 ways this can pan out. The easy way or the less easy way. Okay? The easy way versus the less easy way. This is the easy way. So this is an x squared. Are we all on board with that thought process?
Yes.
So this is 1x squared. I'm not going to put the 1 in front, folks. Okay? X squared, then no x's. Okay, I'm not going to add 0. That's weird. Plus 4 equals the remainder, 0 there. Let's solve for x. Michael, you want me to go over that again? Okay, so are you okay with this was from x to the 4th? From up here? That's where that 1 comes from, okay? And then when we divide it by an x, then this must drop down to x cubed. Then we divide it by, when we found an x, so that drops this down to x squared. So this is 1x squared plus 0x plus 4. I just didn't put the 0x in there. Okay? Destiny.
Whenever you do these problems, do you only take it from...
Get to the squared. Get to the squared, and then you're going to do something else. Go, though. What were you saying?
Do you only... Because you know how you went from that to that step, but you took that one from the start?
Mm-hmm.
You brought back in the x squared. Do you only do it for that number, the first one? That's it.
I think you're trying to come up with a rule that I'm not going to agree or disagree with because the way it's coming out in your brain is not sitting right with the way you're saying it to me. Okay. Holly?
Is that answer 4 like imaginary?
2. Plus or minus. Raymond?
Can you explain again how you got the x?
I haven't got the answer yet.
The x squared plus 4 equals...
Sure. The coefficients here were to the 4th, to the cubed, squared, to the 1, 0. Right? That's from here. Right? And so when I divide all of these by an x, that means that this is dropped down to a 3, a 2, a 1, a 0. Then I divided by an x, this is dropped down to a 2, a 1, a 0.
So they lose...
They lose, yeah, they lose an exponent every time. All of them do.
That kind of answers my question, but say that they started off like a lot higher, so once you got to that point, the 4 still had like a square or something. Then would you apply that?
You can. You can bring it out at any time you want in the process, but you don't want to do it in here until you get down to something manageable. So what would have happened, Destiny, is you pull it out when you get no answers that work anymore. I'm pulling us out early. I'm not going to let us keep on trying for 104 out of all these solutions because I know none of them are going to work. So right now I'm just kind of using some meta knowledge to not keep going. You guys can keep trying if you want. But yeah. If you get every time you get it down to a squared up front, you can pull it out because we all should know how to solve quadratics. So this is the easy quadratics to solve. This is from 3-1. This is all the way back from 3-1 when we solved quadratics by solving for 0 and taking the square root and stuff. So get x by itself. What do? Subtract 4. What do? Square root. When I go from a square to a square root, I get plus or minus. If I square root a negative, I get an imaginary. If I square root a negative, I get imaginary. What's the square root of 4? 2. I have all 4 solutions to this polynomial. X equals -1, x equals +3, x equals +2i, and x equals -2i. That's all 4 solutions to this polynomial. Bethany.
Why do you put the I?
Because I took the square root of a negative.
So if it was a positive,
If it was a positive, I wouldn't have an I on it.
And if it was positive, it wouldn't be complex.
It would not be complex if it was positive.
And you would have been able
It could still be complex if it was like the square root of 3, because 3 doesn't have a square root. But if it was the square root of 4, that wouldn't be complex. No, because that's 2.
so if it's not complex, you're not the answer.
I mean, no. They might try to throw a non-complex solution into this homework. I'm just saying.
So would I have to like note that it's not complex?
No.
It's right there.
No. All right. Now, there are 2 ways they can ask for the answers in your homework. So let's go over the ways they can ask for the answers. So if they ask for roots, zeros, or solutions, if they ask for roots, zeros, or solutions, your answer to the textbook people, gods, whoever they are, right, would be x equals -1. Was it -1 up there? Okay. X equals 3, x equals 2i, x equals -2i. That would be the way you answer it if they ask for the zeros, the roots, or the solutions. If they say write it in factored form, if the question in the book says write the solution in factored form of the polynomial or whatever it might say, then the answer would be x plus 1, x minus 3, x minus 2i, x plus 2i, and equals, your f of x. And the f of x would be on either side. And so that's the factored form of the polynomial. These are the solutions of the polynomial. Yes, ma'am.
Why do you switch the signs?
Going back to when we did yesterday, when we did the find the polynomial of least degree, x equals -1, that means x plus 1 equals 0, x minus 3 equals, remember that? Yeah. I'm not just switching the signs. That is the last example. So if you did 7-1, congratulations. Okay, good on you. I'm going to hand out a 7-1 homework sheet just in case you didn't get started on it or your dog ate it or anything along those lines. I'm going to also hand out 7-2. 7-1, you only have to go to the end of whatever I copied off. I think it's 13. So if it says 15 in your notes, you only have to go to 13. Okay? These homework assignments, if you don't get them to me tomorrow, it's not going to be the end of the world to me. Get them to me next week, Monday. Now, before you start doing anything, let me talk about the quiz tomorrow. The quiz tomorrow, I have not had the opportunity to go through any of the workbook with you, really, except for 7-1 in the beginning. So what I'm going to do, so this is to your benefit, to my benefit, makes my life easier, though it doesn't challenge you as much as I always like to challenge you. I am literally just going to pick workbook problems to do your quiz tomorrow. So if you know how to do all the problems in 7-1 and 7-2 in the workbook, memorize them, even including all the steps shown, then you'll be golden for tomorrow, okay? It'll be 4 questions long, that's it. It's going to be find the polynomial of least degree, find the one with complex roots, find the one with non-complex roots, and then something else in here. Like one will be a factored form and one will be a give me the actual solutions. That'll be the difference. So it'll be 4 questions only. and you'll have the minimum day period to do it. Destiny.
Would it be any word problems?
Nope, I just told you exactly what it's going to be.
Well, I was listening with just word problems and stuff.
There are word problems, not there is. But yes. But there will not be. No. Gabriella.
When is our final?
Your final is Thursday next week. If I have the chance to make it like uber long, I'll make it Wednesday and Thursday. And guys, your grades are due the Friday after. You guys are not in school anymore. Teachers are still working. This is considered just like the end of the school year. So it's like, oh no, I missed. And like if I have a test at the end of the school year, what's the school day after that you can make up stuff? Doesn't exist. So if you are absent, it is a 0 on your final. Please don't do that. Okay? So. If Elias, I'm just going to stop this recording.